Hello everyone, welcome back to my course Web3 Hacking with Python. In this section, we are going to attack the contract, but I'm going to simulate in Remix because we cannot go the real connect or real contract to attack them. It is not going to be legal. So I'm going to use Eternal Challenge level 1 and copy this contract here. You guys can get the contract available on online. Just type in the Eternal challenge, so you get the code in here. It's from the open sapling. If you really want to do and you have some test token, so you can deploy here and directly connect with them. But same thing you can do if you are doing the eternal challenge or real world hacking stuff. So but I'm going to simulate in here, so let's first see the contract here. So this contract is name is called fallback contract, and this one is created in Solidity language 8.0 above anything in between, anything the above of 8.0, because they're using the arrow sign in here. So the firstly there's a contract called fallback, and the mapping the address with the UN256 public contribution, and the owner has a public address is a owner, which is public. So in the constructor they create the owner as a message dot sender, and contribution is like message dot sender equal to 1000 into 1 ether. That's a constructor. And they create the contribution and get contribution and withdraw function, and also receive function. So contribution is public payable because it can be contribute anything which is more than 0.001 ether, because they require is a check statement. If something is lower than 0.001 ether, the contribution is not success, but something above 0.001 ether, the transaction will be successful to contribute. So you can check the is a view function, so you can see the contribution stuff, and you can withdraw. You can see this here is the owner, in this here modifier. So they create a security checkpoint that the only owner can be withdraw the token from the contract. So they check the require message dot sender, because the owner is the message dot sender. It means whoever deploy the contract, they could be owner. They should be owner. So the owner is the someone who deploy the contract. So only the owner can be do the withdraw stuff. So what I'm going to do is I'm going to take a ownership, try to change the ownership, deploy with the one address, and I'm going to take another address to taking the ownership. And if there any token in the contract, I'm trying to withdraw as a new owner. According to the contract, that would be not happening, but I'm trying to do it. Yeah, this is the hacking stuff. So first thing, I'm going to choose the version. So I'm going to choose anything above 8.0. So I'm choosing the 8.26 and compile the contract here. So compilation will be success complete. So this one is a green check. So let's deploy. So this time we are going to choose deploy on Foundry. So first thing, I'm going to run the Anvil in here. Okay, but before we deploy, let's see the attacking code here. So here is the attack code. So first thing, we are connect with the local provider Anvil. So we use the local host and 8545, and connection successful or not, we check. This time we are going to withdraw also, so using the private key. But if you're doing real wallet or real wallet, then you don't need to show a private key with anyone, but we are using the test account, so it's okay to share the private key here. And we need to add the attacker address in here. So this is going to be a link. I'm going to show you where you get those key things stuff. So first thing, we are going to copy the private key. So I'm going to copy here number one. Okay, I'm going to do the number two account here. And I don't know what happened with my copy thing stuff, but it's okay. I'm going to copy all those things here and create a new file and paste it here. So I'm copy the number two, copy it and paste it here. This is going to be attacker address and number two copy. So I'm going to do private key, copy it and paste it here. So first thing, I'm going to do these two things. So it's mean that the attacker address is going to be this one. Okay, so let's deploy the contract in Remix. So I need to choose here is Foundry and the same address 127.0.0.185.45, which is same here, right? 85.45. So just click OK and now connect with the Foundry Anvil. So I'm going to deploy here. Sorry. Why it take too long? Okay, give me a sec. Let me pause the video and check what's going on. Okay guys, now it's working. I'm deploy again. Just click it and deploy. So now we get the contract here. So you can contribute, withdraw, contribution with the address and get contribution and owner. So the left first you can see the owner address here 0fx39. Okay, so just copy the contract address from here and paste it in contract address here. Okay, and we are going to paste it in API key. So where we get API key is just click the compiler and copy the API key here. You can save it in the JSON format, but I'm just directly paste it here. So it's just like we are going to add the contract in contract address and API, and we are going to transact. So send a transaction and sign it with the account sign transaction with private key using the private key here. Okay, sign the transaction with private key and we create a new transaction, raw transaction, and we get the transaction hash to the send transaction here. And I'm going to see the owner, get owner, return the contract function owner dot call. So they show in the actual owner name and owner information. So get owner, get balance, contract balance, and get contribution. They have a function, so we are going to use those function and we get the data from it. And we are going to check the contract owner initial contract owner's address and the contract balance. If attacker do the some contribution, they show in the here contribution address. So first thing, I'm going to send the small contribution to the address. So according to the attacker address and from attacker address to contract address, and its value is 0.0010. So I'm going to contribute 0.003 eta because last value is 0.001. So I'm going to change the 0.003 is a gas value, and I'm going to pay the gas price in 5k. The ounce is attacker address, so transaction going to be attacker address, and the contribution data if a contribution is step 1 to make the contribution. And also I'm going to send directly send to the account to activate the receive function. So I'm going to send attacker address to another 0.001 ether. Transaction 2 is successful, so I'm going to verify that the owner is, if address 2 is sending the ether which is less than more than the amount, so owner going to be the new owner, so it's print out if the new owner we claim it. Otherwise not successful, then they showing the exploit fail and current owner address, and thus withdraw all the ether. If there's something involved, something added in the contract, they withdraw the all the token from the contract. You call the withdraw function. We're doing that transaction, and we are going to check the balance if final balance if 0, so we all drain the final balance. That means that the contract has some balance, then we will withdraw the contract, but the main point is we are going to be take the ownership. So everything is set up, and I'm going to run the code. So Python take fallback. Okay. Sorry, I think this one just not 0.09. I don't know what happened. Maybe it's something about gas, but this is the first time when I ran the transaction is showing like this if successful. So the contract has initial balance is 0, attacker contribution is also 0 contribute, and we made a new contribution and we send the ether, and takeover is successful. So because you can see the difference between two ownership, 0fx39, the new owner is 0x7099, and last also is different. So it's a successfully we can take over the account, take over the ownership, but at the time unfortunately we don't any balance in the contract, so it's a 0 balance. That's why we didn't withdraw anything. If they have some balance, it's also withdraw by them. This thing happened because of, I think it's a problem with about the connection and gas fees. That's why they didn't change the ownership name here, but you can see the things. Okay, because when you deploy the contract and run this code, the attack will be walk. Don't worry about that. Okay, so see you in next video. I think you should take a rest and see you in next video. Bye bye.